Hello, everyone. My name is Susan Kudalakis, and I'm Senior Marketing Manager here at Progress. Welcome to our Improving Your OpenEdge Database Performance webinar. So let's start by quickly introducing you to your speaker for today, Roy Ellis. Roy has been with OpenEdge for 30 years, starting in tech support, moving to development, then to product management, and finally the last 4 years as the Director of the Managed Database Service team. He has been involved in nearly every product in OpenEdge, most recently helping to deliver PASOE, replacing the classic app server and web speed. I'm really excited to have Roy with us today, and now I'll turn it over to him to start the discussion.
Welcome, everybody. Thank you very much, Susan, for the introduction. Again, we're going to be talking about the Progress Database Performance Tuning. Before we get started, I just want to go over the fact that we're not going to go over all the database performance tuning things that you can do. We're going to go over the big ticket items, the biggest bang for your buck. To go over all the performance tunings would take several days. We have a class of that. All right, so let's see what we're going to talk about today. So today's agenda, we're going to start with an overview. I don't think you can do performance tuning unless you understand all the pieces that are involved. So the overview is going to take us through that. Next, we're going to talk about monitoring and tuning. You can't tune something without monitoring or without knowing what's going on. So we're going to cover both the monitoring and the tuning. The last big thing for performance is reporting and how you can move reporting off your production box. And we can talk about that quickly. And lastly, how can we help, right? As the manager of the database administration team, I have people that do this all the time. They've got 20 plus years experience, all of them. So they know how to tune these things. And I've learned more from them than when I used to do it myself and many years in Progress. Okay, so let's go ahead and get started. Everybody knows the Progress database here, right? We all know what it is, but I don't think everybody understands how it interacts with all the different pieces. Right, there are 3 parts to the Progress database. There are the database files on your disk, which are .ds, right? There is the buffer pool in RAM, right? Nothing gets written or changed on disk. It moves into the database buffer pool, which is in your memory, and then it's changed and moved written back to disk, or it's written to the before image file. So again, we talk about the database files, and that's what most people think. This is my database. This is just 1/3 of the database, right? We keep all the files on disk on the database, and then when it needs to be something wants to be read, or if it needs to be updated or deleted, it gets read into the database buffer pool, which is a piece of memory. But think of it as a little piece of your Progress database up in memory. Okay, and then once it's in the database buffer pool, if you want to change it or update it or delete it, what we do is we write it to the before image file, right? So that we know what it was like before you made a change. And this way we can go back if anything happens or you back out of the transaction, we can go back to the original data that was in the database. And this keeps your data concise, right? No database corruption here in this case, right? A couple other things here, the database buffer pool will write asynchronously to the database files, but it writes synchronously to the before image file. So these are the 3 parts of your database, and these are the 3 parts that we're going to use to help your performance, to tune your performance. Okay, so those are the parts of the database. Where are the bottlenecks? When I started in Progress 30 years ago, I had someone sit down and help me understand how to performance tune. And he wrote up on the board, on a whiteboard there, and he wrote all these pieces. He said there can only be bottlenecks in 3 places: CPU, RAM, and disk. Later, we both conceded that network is a part where we want to look at. So these are the areas for performance bottlenecks, and you have to understand how they interact with each other when you want to go make changes. The network is not a database performance issue, right? However, being on the latest version will give you much better performance for network. And there are some very important networking parameters that can help your network speed, your client to the database. We won't go over those today because they're not database performance things, but I thought I should mention that to you. CPU. CPU is only a problem if you don't have enough, or you're swapping, or you have bad code. So if you see problems with CPU, that being a bottleneck, usually swapping or you have bad code. There's also a setting which can cause you CPU problems. So it's nice to understand what can cause you CPU problems and make sure you have enough, right? So you want to make sure you always have at least 80% coverage or only 20% available at your busiest times. So that's one place that can cause you a bottleneck. RAM can cause you a bottleneck. It's only a problem if you don't have enough, right? If you need more RAM for your database buffer pool and you don't have enough, that is a problem, and that's probably a bottleneck for your performance. So make sure you have enough RAM. Make sure you have enough so you're not swapping, right? If we just if we set something so, hey, my database buffers aren't getting swapped, but actual RAM is getting swapped off to disk, that can cause you a problem. And lastly, your disk. Your disk is the slowest system resource. It can severely affect your performance, and minimizing the use of the disk as much as possible can improve your database performance immensely. Now, some people are going to say, hey, I have a brand new SSD drive. It's wicked fast. I don't have to worry about that anymore. We're working with customers right now who thought that was the case. And yes, they got good speed on the disk, but you still have to tune your database. They started to see other problems because they weren't tuning their database correctly, and it was causing problems in another area. So yes, having fast disk is great, but also having it tuned well so you're not causing contention on your disk is very important. So we'll move on, okay? So my first question is, hey, do I have good disk? Do I have good disk speed, right? How do I know? And we have a tool we have out there where we basically truncate a BI and then we grow it, right? And this gives us information on how fast your disk is, right? And it's very tied to how the progress database works, right? Some people will say, hey, I ran this other test and it ran fine. I said, that's great, but that's not how the progress database works. Let's use the BI grow test and verify it works. And you're going to do this with a variable extent and a fixed extent. You want to do that so you know, hey, I don't know how slow my disk is. Let's do it with a variable extent, which means I have to go out and grab more disk space as I'm growing this. And that'll tell you the low end, right? And then you can run the fixed extent, which will tell you the high end. How fast can it be if I allocate the disk in advance, all right? And that will also teach you that, hey, fixed extents are much faster, and I want to use that for my AIs, my BIs, and my my DB files, right? So run the tests several times to make sure something wasn't happening busy on the machine, and you want a BI grow of less than 10 seconds, right? We're building at a certain size, and if you have that, you're doing great. So again, we will be sending you the slides after this, and this is a K-base on how you can actually do this test. So I'm not expecting you to memorize this, so you have to run it later. All right. So we want to make changes and tune our database, but how do we know it's running slow? A lot of customers say, hey, I'm not getting any complaints. And that might be the case, but if something slowly gets slower and slower over time, people don't notice it, and they don't necessarily complain about it. Only when something happens quickly. So you have to monitor, right? You can't just say, "Yep, I'm going to tune my database today," and start changing things, and you can't also just monitor for one day and say, "Hey, I need to change these things." You need to monitor for a while. So let's talk about one, how you can monitor it, and what you find, and then how you tune those things as you move forward. So there are a couple ways to monitor the progress database. The first one is Promon. It's a command line utility for gathering information out of the database. A lot of things you can do with this are online, but you can also go ahead and screen scrape it and get information so you can gather it over a certain amount of time. This is what we're going to use today. Okay. There is something called virtual system tables, which has been in the progress database for many releases, and it gathers those metrics and keeps it in your database. However, using that means you're going to have to write ABO code, or if you're as old as I am, 4GO code to gather this information. So we're not going to go through that today. I want to get right to tuning, so we'll use the Pro Monitor that is built in. If you want to start looking at VSTs and start writing your own code for monitoring, there's a K-base at the bottom. Also, this is how my team monitors customers' database for our MDBA service. We have VSTs we've written, and that's how we get the information out of the database, so we can help our customers keep their databases tuned. All right, so how do I use Promon, right? So set up your progress environment, so you can type Promon, it can find it, and then just Promon the database name, right? You have to be on the same system. This isn't something you can do over a network. And when you run it, what you're going to do is get this character base on the right side, right? So this is your menu system. We're going to go right to the R&D selection, right? So into your selection at the bottom, we're going to type in R&D, and we're going to hit return. This is going to give us this new menu, okay? Status displays, active displays, other displays, administrative functions and adjust monitoring options. Maybe when you get a chance, wander through and take a look at all of these. But what we're going to do today is we're going to look at activity displays. That's going to give us information on what's happening right now in our database in a menu. So this gives us a summary, it gives us servers, buffer cache. A lot of these things you're going to be looking at if you're trying to debug a performance issue. But again, we're going to work on the biggest bang for your bucks here. Okay, so we're going to go ahead and look at summary. And here we have a big summary screen. Okay, it gives us a lot of information. If you look in the upper right corner, hey, this database has been running for 21 hours. So that's when we're going to give you the information from. On the left is all the events, commits, record reads and writes. On the right side, we continue that. A lot of information on the bottom, how many servers, how many users, how many are local, how many are remote, how many am I running a BIW, an AIW, and APW. But let's talk about how are we doing in gathering information from the database and putting it in memory from the disk, okay? So if we look at record reads on the left-hand side, we had 17,250 records we tried to read in a second, right? So we wanted 17,000 records every second, okay? On the right side, it says, how many times did I have to go to the disk to get this information? And I had to go to the disk 453 times to get those 17,000 records. So my buffer hit ratio is 38, which is pretty good, right? That's not bad at all. We want to keep it under 100. The problem is this sample is too long, right? This has those very quiet times in the middle of the night where the database wasn't doing anything. It's not the information you want, right? So what you want to do is go ahead and hit return, and what it'll do is give you a 10-minute sample. What was the last 10 minutes? Now we see that during this period of this time of the day, we had a hit ratio of 78, which is again below our expected 100 per second. But this is more, if it's a busy time of the day, this is more representative. So don't go to the first screen and just get the information. Go do this to get the information and do this math, okay? What we do is something called the database health check for customers. And this is one of the reports we get. We're running ProMonitor, we're scraping the screen, and we're writing down those buffer hits, right? How many records did I want to read? How many times did I have to go to disk to get it? And this customer here, which is not the same customer we were looking at before, does well at night, but is reading from disk an awful lot during the day, right? And again, the disk is your slowest point at any system for performance, right? So there's your bottleneck. We're having to read from the disk an awful lot. So how do we fix this? So to fix your buffer hit ratio, I've said already, you want to have 100 reads per second or less. There are three things that affect the buffer hit ratio. Memory usage and allocation, that's your buffer pool, right? Those things you're moving from disk into memory. So how can we do more of that and have more in memory at a given time? There's also database scatter and fragmentation. How many times do I have to read the disk to get a record? And the last thing is database queries. If we're doing a lot of querying and querying a bunch of data and having to load in big tables to do the querying, then we're pushing data out that might be part of your daily business application. So we'll jump on 1, 2 now. We'll look at 3 later when we talk about reporting. Okay, the memory buffer pool, or the dash big B as many people call it, right? Having as much memory having as many records in memory as you can gives you the best performance, right? So if you have a record in memory already, then you don't have to go read the disk for it. A quick question, a show of hands. uh, if you wanted to, when we read a record into the memory, do we pull just the record up or do we pull a whole block up of memory, right? So if a record lives in a block and there are several other records in that block, what we do is we read the whole block in, right? We don't just read the record in and then try to write it back to disk that way. We read the whole database block in, which might have space in it, right? So if we have to add or update it, we can just do it right there in memory. Also, that way too, if it's like a customer record, hey, I might need another customer record that's in that block. So we work in blocks in the memory buffer pool, right? So So you want to set it up. How many blocks do I want to keep in the memory buffer pool? And we usually start with 10% of your database size. That is just a guideline, right? If you can put 100% of your database in the buffer pool, you're going to have the fastest database you can have for a memory disk and that type of thing. That's not really plausible for a 5 terabyte database. In fact, 10% might not even be plausible. So we use this as a place to start. And then we watch the buffer hit ratio. How many times do I have to go to disk? And we can adjust it up and down, okay, based on that. It's just a place to start. So there are other things that affect this, right? If you're an old version 32-bit, you can only have so much buffer. So get to 64-bit versions. And how do I do this, right? So I shut the database down. This gets created as the database is started. So all you have to do is shut it down and then change it. In newer versions, you can change the buffer pool size on the fly, right? So if you're in 12.8, you can change this on the fly without having to shut the database down. So if you see you're having poor performance, too many disk reads, you can go ahead and change this on the fly. And the dash big B, that's the buffer pool size. And what it does is it's the value times your block size. So if you have an 8K block size database, which you should have, don't use 1, 2, or 4 anymore. Use an 8K block size. The operating systems we support now support that. Then you would set the dash big B to 10,000. That'd be 82 megabytes of memory. Okay, so so that's how you set it. Figure out how much memory you have, how big your database is. See how close you can get to 10% and try that. And then monitor, right? Again, you've made a change. Make one change at a time when you're performance tuning. Don't do 3 or 4 because you don't know what gave you the biggest bang. And then go back and modify it as you go. And again, in version 12, this is something you can change online. Just check the docs. All right, what else affects buffer hit ratio? Well, if a record fits in a block, then we have to call one block up and I have the whole record. If the record is too big and it had to be moved to several blocks, then I have to call up several blocks in this case. That can start at the beginning because the record is just so large, I have to call up several blocks. But many times what happens is I pull a record, I have to change it, I need more space. That block is already full. I can't squeeze it in that one. So I have to write it to a different database block. So now that record is fragmented to 2 blocks. If I have to change it again, then I have to go to a third block. And what that means is I'm calling up one record, but I'm reading in 3 blocks worth of data every time I do this. And that again is putting a strain on your slowest part of your system, the disk, right? So that's record fragmentation. We'll talk about how to tune it soon, but understanding record fragmentation can cause the problem is a step here. The other things that can cause slow disk reads is physical scatter and logical scatter, and we'll move on to the next slide to that. So physical scatter. What you're seeing on the top here is different tables represented as different colors in a type 1 database, right? So type 1 storage. That's version 6, 7, 8. And what you want to do is you want to move to type 2, which is at the bottom. So here at the top, we're saying, hey, let's say all my customer records are in red. I want to go ahead and get a list of all my customers who have invoices, let's say. So now I've got to go all over the disk to get my customers, right? They're not all in one place, right? So the bottom here is type 2, which means I keep all of my database records in one place. I keep all my indexes for those in one place. I keep all, and then I pick other tables and I put those, maybe having multiple tables in one area because they don't get access very much. So the physical scatter can definitely slow down, how quickly you can access the data off a disk, right? So again, type 2 is what you want. It's not part of the performance tuning here, but you should be on type 2 for anything. If you're not, move to type 2, take the time, take the hit. You'll have some really good advantages there, including less fragmentation, faster queries, and that type of thing. And the last thing is logical scatter. And that's basically indexes, right? How do I find something with an index? Sometimes with a tree, I might have to move down 4 levels to actually get the record I want. So I've had to traverse the indexes 4 times to get to the level I want. And that's what you want. You want to have 1, 2, maybe 3, but you don't want to have your indexes spread out all over the place and having to make several jumps to get to your record. All right. So how do I know if I have fragments or scattered? We do a table analysis with that. This is just a representative. My largest table has 1.3 fragmentation. So if I want to, every 4th time I want to read a record on average, I have to go get 2 blocks. Okay. And that shows that. And the scatter, we have one table, probably another very busy table, that it has a lot of updates and deletes. So they're being spread out all over the disk, and that slows that down too. So how did I get this information? Well, there's a tool out there called table analysis and index analysis. The tab analysis will get you that information we were just looking at. Index analysis will get you, how well your indexes are working. There is something called DB analysis, which will get you both at the same time. This can be run online, but it shouldn't be run at busy times, right? Run this on the weekend, once a week, run it at a slow time during the night, so that it won't affect your performance, okay? These are K-bases or documents on how to actually run these things, and you can get the same information out of the VSTs by running 4GL code. So use the tab analysis to look for your scatter, and use the index analysis to look for how well your indexes are compacted. Usually if you get a percentage of 60%, we think it's time to compact that index. And that's something else you can do online, is compact those indexes to get the best performance out of your indexes, which I think I say on this one. Okay, so that's your index compaction, right? If you see less than 60% or in the 60% range, go ahead and index compact your indexes. There's a K-base on there in the communities, and to tell you how to do it. That's something you can do online, but again, don't do it during busy times. Do it during a slow time. We run these for our customers usually once a month or when they start to fall out of range to help their performance. Now, the top part of the slide is how do I fix a fragmentation and scatter? And that's not as easy. The only way to do this is to dump and load your database, which means to take all the database out, put them in tables, and then load them into a new database. That's the only way to fix it. There's several ways of doing it. There's 3 ways of doing it, but that's the only way to fix it. Especially if you're in type 1 areas, you'll see fragmentation and scatter grow much higher than if you're in type 2. So if you're on type 1, move to type 2 and do a dump and load. The first way of doing a dump and load, that's a dictionary dump and load. It's very easy, right? What you're doing is you're going into the data dictionary, you're saying, hey, dump my schema to files, dump all my data to files, and you get ASCII tests, you can look at them. And then when you're all done, what you do is you create a new database, and you open the data dictionary, you load the schema, you load the data, and everything's in there, right? So you can do everything by just clicking in the data dictionary and it'll be done. However, it's slow. A large database can take you days. A very large database can take you weeks doing it this way. The second thing to do is a binary dump and load. There's a K-base on how to do that. This is done from the command line. Binary dump can be done very fast. It can be multi-threaded. The load is very fast, but it has to be single-threaded for tables. But you can't do multiple tables at once. But the problem is then you have to also do an index rebuild, right? Because it's not building the indexes as it's going in, it's just putting the records in. So when you're done, you have to run an index rebuild. Even though you have to run an index rebuild, it's still much faster than a dictionary dump and load. You have to build the indexes at some point anyway. So this is just much faster. So that can get a large database down to several hours, a very large database down to several days. The last way to do it is a pro to pro. This has minimal downtime. So if you have a 2 or 3 terabyte database and you can't be down for days, your business can't be down for days, we can set this up. And basically what we do is we use the Pro 2 technology, which we'll be talking about later, to stream data over to another database while you're still using your current database. And the Pro 2 keeps everything in sync. So once everything's been copied over and everything's in sync, you maybe have a 4 to 8 hour time to shut it down, convert it, and bring it back up. So a little bit of time at the front, a little bit of time at the back, but you don't have a large downtime to do this. So, all right, so that's fixing fragmentation and scatter and index compaction. Those are all the things that affect the buffer hit ratio. Checkpoints are the next big thing that can really slow your system down. And what checkpoints are, they're designed to ensure data integrity. Hey, we are going to make sure that everything is written from memory to disk every time we get to the end of a BI cluster, right? And a BI cluster is something you set at startup or you use the default that comes with the system. If there's data in the database buffer that hasn't been written to disk, we will stop everything to write this data. Okay, so if you have a bunch of updates you're doing and the BI cluster gets hit and there's a bunch of stuff in the database buffer that needs to be written, everybody pauses. So if you have a database that seems to be hiccuping and pausing every now and then, you probably are having checkpoints at that time, and you have things that have to be written. Okay, so how do we fix this? Two ways, right? We make sure that we don't checkpoint too often, and we make sure there's nothing in there to actually do when the checkpoint happens. So how do we know how we're doing with checkpoints? Again, we're going to use the Pro Monitor tool. We started R&D. We're going to go to 3. We're going to go to 4. We're going to do the checkpoints, and here's what you're going to look at. The frequency tells you how often are you checkpointing. I'm checkpointing 17 times in that poll frame. So it looks like almost every second in most of these. It's also taken me 16 seconds to actually write the information in the buffer pool to the disk, right? So it's almost like I'm writing all the time and checkpointing every 17 seconds. So this customer is having a lot of slowness on their system. Okay. This is again something from our database health check that shows this customer is doing pretty well with checkpoints, except certain times of the day. And when it's over 10 checkpoints in 10 minutes, basically, then they'll start to see slowdowns. Okay, so in this case, this customer needed some more tuning, and here's what they had to do. Right, the first thing you can do is adjust the frequency by increasing the BI cluster, the before image cluster size. That's done by shutting your database down, truncating your BI, and then starting up with a new BI cluster size. All right, you don't want to check more often than 1 minute. You probably don't want to go more than 5 minutes, right? So knowing how often you're checkpointing now gives you an idea of what you should probably set your BI cluster size to. Common values are 8 megabytes to 32 megabytes. Okay, we've seen great performance hits here. Um, so if you're using the default, if you're not setting it, the default is 512 or half a megabyte, and that's too small. You're going to be checkpointing too often. Okay, so go ahead and take a look at what you're doing now for checkpointing, and think about values in the 8 megabyte to 32 megabyte. All right, so that changes the amount of times we stop to check to see if there's anything in the buffer, which will help with checkpoints, right? We won't be looking at it. The second thing to do is run writers, right? That is a process outside of the database that keeps track of this information, right? The database is going to do this anyway, but your database process is handling requests from customers, it's writing things back and forth to the disk. So let's take another process and run it outside the database that will take care of writing to the BI file, right? So even if I do hit a checkpoint, there's nothing to write, so it just moves on. So there's no lag there at that point. Again, I talked about the BIW, which is the before image writer, a different process that just keeps it clear. While I'm here, I might as well talk about the after image writer, which is the AIW, and that will make sure that there's nothing that needs to be written at the checkpoint time for the AI writing, because it does the same thing once you turn on after imaging or replication. So you want to make sure two things: the cluster size, the before image cluster and the after image cluster are the same size when you're running after imaging and replication. And the other thing is you want to make sure you're running a writer for both of those. The second thing here, just for a complete list, is APWs. And what those do is they write data from the buffer pool back to the database disk, right? So on disk. So those are just keeping track of things and trying to move data in and out before we have to stop everything to grab a whole bunch of data out and grab a whole lot of data in. So always run a BIW, run an AIW if you're running after imaging, and then take a look at your APWs. You don't want them idle, so you don't want to have too many. But you also, at least I think in most cases, want to run at least one. A little word of caution, it might be tempting to go ahead and create a BI image size that's more than 5 minutes apart. The problem there is every time we grow the BI file, we do it in cluster sizes, whether we're growing it in a fixed extent or a variable extent. So that can also cause slowdown. So if you make it too large, then you're going to actually have slowdowns while we're just trying to get space on the disk. So, if I only checkpointed once a day, I'd have great performance. Now, that's not going to work. All right, let's talk about latches. What are latches? Latches are system resources that we use to keep data integrity. Okay, so I want to make a change. I ask to lock this change, to get a latch from the operating system to lock it so I can make the change. And then when I'm done, I give that latch to the next person so they can lock it and move that to disk or whatever the actual thing is that's happening. It can be memory latches, it could be write latches, it could be transaction end latches. There's a whole bunch of latches. So what you don't want to do is be waiting or timing out on latches. So at the very bottom there, you have latch timeouts. So if I'm trying to get a latch and I try a few times and I can't get it, then I go to sleep, right? I spin and I go to sleep. Now I'm going to wait a second before I wake up and try to go get that latch again. So if you have a bunch of people behind you, everybody's waiting multiple seconds to get to their latch so they can do what they need to do. This can cause a performance issue, right? So there's a couple of things you can do to fix this. And before I do that, let's talk about this one. This customer, again, during busy times of the day, we're having a lot of latch timeouts. So, and this meant processes were waiting to get these latches so they could do what they need to do to move on. And that can cause people to line up behind it. The easiest way to fix this is to increase your dash spin parameter, right? It's already running. There's a value automatically for spinning on a latch. But if you increase it, it says, think of your 5-year-old child at the back of your car going, are we there yet? Are we there yet? Are we there yet? Are we there yet? This process is just going to spin and say, hey, is my latch available? Is my latch available? And many, many, many times they'll get that latch much quicker time than if they had to wait the second and wake back up and go get the latch, right? So increasing your spin parameter can actually help you with that. It says here, you don't want to increase your spin parameter if you have less than 20 CPU idle. Usually that's not a problem I've seen. Most people like to have a lot of extra CPU on their system, but I want to also caution you that creating a very large spin parameter, like 2 million, could also cause a CPU bound, right? So again, you don't want to make a change to stop one bottleneck to create another bottleneck. So increasing your spin parameters is probably good. The default is too low. And that's something you could do. There's also a nap max parameter, which is, hey, how long am I going to nap? You could decrease that so that you're waking up quicker after you spin and have to go to nap. Okay, so these are the things that will help you with latches. Again, customers who had very fast disks weren't doing these adjustments, and they started having other bottlenecks, not on their disk, but these types of bottlenecks here. So again, all of these things are interrelated. You have to understand the CPU, the memory, and the disk before you make changes to anyone. Now, we've done a pretty good job making sure we're not waiting on latches, we're not waiting for checkpoints, that our database disk and buffer hit ratio is pretty good. The third thing that really, really slows down many, many databases is, and what that means is you're using your production database to do your business, but you're also using it to do business reports and maybe creating a large sets of invoices or anything like that. And if you're constantly loading large amounts of data into memory to do a sort for your report and to write it, then you're constantly pushing out other data out of the database, which means the disk is writing a lot to get the data in and read it out. So, a lot of reporting can definitely affect your production. It's definitely a cause for some issues that some customers had. So we're going to talk about reporting here, and moving the reports to a different database is what many customers have done, and it's really, really helped their productions. There are two different ways to do that. One is to run like a Proto-SQL or a Proto-Oracle, or even a Proto-Pro, where it moves that data to a different database, but it just moves the data you want, okay? And then you can run the report on that SQL, Oracle, or even a different Proto-Pro database. Or what you can do is you can go to the OpenEdge Replication Plus, which is a high availability and disaster recovery system, but you can also report on it. So let's go a little deeper into each one of these. Okay, so Proto-Pro, or Proto-SQL, or Proto-Oracle. What we have here, we'll just talk about the ones that go into a SQL type database. You have your OpenEdge database. We usually set up CDC on it. So anytime there are changes, the Pro2 notices it. And what it does is it takes that information, it modifies that record so that it fits in a SQL database, because they're not all necessarily one-to-one. So it does a change, a transformation of that data, so it goes into SQL database. This is selective, right? You don't have to do all your tables, right? All I want to know is my invoices, my customers, my shipping, everything else I don't need for the SQL database. So this allows you to move that data into SQL, and then you can use Power BI, Tableau, Click, you name it, to go ahead and get that data out of the SQL database. This means you don't have to have OpenEdge skills to write the reports. Power BI is basically a point and click type report writer. So you could write your own reports that way. And a lot of customers who've set this up, we have, we're getting near 1,000 customers who's using SQL. They need their SQL database, their reporting database, as much as they need their production database. It's as important to the business. So this is a very good way to move data for reporting. Okay. And again, this is near real time, no such thing as real time. A change is made in the OpenEdge database. Pro2 has several threads taking care of them. As soon as it notices it, it gets it, it transforms, and it sets it to the SQL. Okay. Another way to get reporting, which is very, very different from the Pro2, is to run OpenEdge replication. And what we do here is we make an exact copy of your production database somewhere else. Okay, so we actually take a backup of the database, we bring it up over there, and we start a process that keeps everything in sync, right? So if something changes on the production, it changes on the target. You can't make changes on the target, right? Everything that happened on production, the target is read-only, it's not changeable. But what you have here is an exact duplicate of your database. And again, within near real time, usually less than a second, a change is made in production. It shows up in the replicated database. This gives you the advantage of high availability and disaster recovery. If your primary one crashes or you lose a disk on it, you can spin up the target database as the new production database, and you can bring it right back and running. But again, this is an exact copy. Not like Pro2, we only take selected things. In this case, we take every single file field index, and we replicate it over to the replication database. The added advantage here, if you have the plus, is that we will allow you to use this database as a read-only database, so you can make reports against it, right? If you're still ABL and 4GL centric and you want to use that to write reports, this is a perfect way to do it. And it gives you both. It gives you both things, right? It doesn't. You can't really use Pro2 SQL or that replication for disaster recovery, but you can use disaster recovery feature and then use reporting on it. So again, two great ways to get reporting off of your system, off of your production system, not only the load on the database, but the load on the system to help performance of the production database. Okay, we're nearing the end here. How can we help? So I've talked about it a couple of times. We do database health checks for customers. We're constantly doing them. We have customers who every couple of years come back to us and ask for another database health check. What they found is their business changes, their database size changes, their users change, their application changes, and every couple of years coming back and doing a database health check gives them a list of things that they know they can tune on their database to keep their database running highly performant and highly stable. Okay, so this is a feature. It's a very small consulting time, and we do that all the time. And you've seen some of the charts we have there. So it's a good way to keep your database if you don't want to do the monitoring yourself, or if using the ProMon you just don't have the time for it. It's a good way to keep up with your performance. Again, don't need to do it a lot, but every couple of years, maybe if especially if your business is changing, it's very helpful. Also, my team can help with almost any task. We talked about Pro2 and we talked about OpenEdge replication. There's also CDC, change data capture, TDE, transparent data encryption. So there's a lot of things that we can help you with your database, everything from scripting to that type of thing. So we can help you with that on this database team. The other thing we have is we have a service that will monitor and alert on your database, your app servers, your disk, your memory. And that way you have somebody always watching your database, but because we gather information out of the VSTs, we also can use that information to do constant tuning for performance and stability. So if we're doing our job right, you don't have issues that we have to alert on. We just keep your database up and running and fix those problems before. Lastly, we can monitor Pro2 and OpenEdge replication. That makes sure that the database is flowing well to those, so you're getting near real-time data so that you can use for your reporting if you decide to move your data off of your production database to get that type of performance. There we go. That's the end of my slides. Susan, do we have any questions?
We do. So Roy, the first question for you is on hidden penalties. It says a hidden penalty of huge -B is growth of the page table in memory on Linux. Is that something that people should be mindful of?
Yes. Again, if you're running in shared memory mode and you increase the -B, then there'll be more need for those page tables in memory. So if you're running in shared memory, you have a lot of extents, you have people connecting, everybody has to have a page table, and that can add up very quickly. This is a good point, not just for the page table though, right? A huge -B can cause other problems. So you've got given the database a lot of space, but maybe it's being swapped out by the operating system. So you need to look at that. Another thing is um, that we found recently, and I just lost it, so I may not be able to tell you. Another thing that somebody did recently is, oh yeah, they went online and they asked AI or Google, what should my best way to improve the speed of my database, and they said, well, increase your -B, right? Put more in memory. So they just went ahead and I'm sure they got 10%, right? Because that's our guideline. And they tried to do that. They had a very large database, and the database wouldn't start. And I'm sure it's because the memory on the system could not handle it. So making these changes can't be done in a silo, right? So if you're increasing your -B, do you have enough memory? Do you have enough swap just in case? How's your page table? Which your page table memory does not show up in the typical tops and things. So you need to know about that. Um, and know all these things. These tuning things can't be done in a bubble because, right, there's three parts of the places where they can cause a problem. So great point. Thank you for bringing that up.
All right, Roy, I am seeing so many questions come in. Very popular topic today. All right, so here's another one. If a 512 KB is too small, why is the default targeting regarding the BI image cluster size? Why not make it 8 megabytes by default?
That's a great question. I'm sure it's just history, right? When we started out, our databases were smaller. They weren't as busy. So I'm sure it's just a leftover. Um, so that's a recommendation to development. So I would recommend if it makes sense to go ahead and add that to our ideas portal. Just search for OpenEdge Ideal Portal, and you'll find it. You can put an enhancement request, and and you can put it out there, and people will vote for it. And when you get a lot of votes, people that gets added to the product. But this is a real good one. You're right. It's never seems to be right for any customer. But then by the same token, whatever we make the default, the default is always wrong. It's just a number to get you started with. If you have a bigger database, you have a database that isn't as busy, then it may not be the right size. So thank you for that question.
All right, here's another one for you, Roy. We noticed that binary load is not possible when replication is active. Is that true?
Yes, and it makes perfect sense, right? You want a frozen section of your database. You don't want things changing. You don't want anything happening. So you disable replication. You shut the database down. You run a binary dump and load. You create a new database, right? And then you have to start the replication over on the new database anyway. Yes, binary dump and load is not possible while it's running. Even doing a dictionary dump is you could do it, but if records are changing on the fly, then it doesn't really get you what you're looking for. So yes, that is correct. Those are the steps. I'd have to verify them, but those are the steps that I know of to do that. So.
All right, so there's another one about CDC. How does CDC impact the database?
Okay, so CDC is change data capture, right? And that's a feature that, gosh, came out in 11, I think. And the idea is you set up a policy on your database, and anytime data changes, in your policy says anytime data changes in this table, write a note into the CDC table, and the CDC table can say, hey, this record changed, so I can just go find that record, or the CDC can get me not only that the record changed, but that the record the new value is this, or the old value is this, the new value is this. So you're writing more to the disk when you have CDC. Okay, so on a specific table, if it's very busy, you're doing a lot more writing because you're not only writing the change to the record, but you're also writing the value to the CDC, all right, to that table. So it can impact the database. If you're just writing, hey, rec ID so and so changed, then it's not as big of an impact as if you were writing, the before image and the after image of that record and that type of thing. So yes, it can have an effect, and if you're already doing too much disk or you're already having performance problems, maybe not something you want to add until you've got those things fixed.
All right, so let's move on to the next one, Roy.
Mm-hmm.
So what is the best way to move or migrate old database area type 1 to a new database area type 2 with minimum downtime? The person also went on to write, I know I can table move on the fly, but it's lock that table for write, so it's actually not online for our app. Maybe I should have said locked that table.
That is correct. You can do a table move, but the problem is while you're doing the table move, you're locking that table. Now other tables are fine, but very rarely is the table you want to move the one that no one's using anyway, right? So there are other ways. We have a program we've written that will copy files out of an area and do it in groups and move it from one table to another, which isn't the actual utility to move a table. So sometimes that will work. We've had customers with a lot of information in the schema table, right, which is your old default type 1 area, and we've had to move it in. That is possible. The only way to do it other than that is to dump and load the data from one database to another one. And those are the ways we talked about, right? The dump and load, ASCII dump and load, binary dump and load, and pro to pro. If it's a large database and it's going to be down too long, pro to pro is the only way to do it, because you stays up and running while you're doing the actual movement of data, and then you just have a little bit of work at the beginning and the end to break it and get it running again. So those are the ways that there's no magic here, unfortunately. Like I said, we have my team has written some tools that can do some of this. And do it in groups so it doesn't lock the table as much. But again, not something you want to do when it's busy, and not something you want to do with very large tables. So.
All right, Roy, we're going to keep going.
Wow. All right.
Yeah.
See if we can fill this whole time.
Yeah, we're gonna fill it today. Is it possible that the replication target would be slower to pull data than the source production server?
Not if it's sized correctly, right? I mean, so you're just looking for data, probably for reporting. We usually try to say have a database, have a machine about the same size on the replication server as you do on your production server, and that's not for reporting, right? That's for, hey, my primary source has crashed. I'm going to have to run now on the source box, which means I'm probably moving not only the database over there, but I might be moving users onto that system. I might be running PASOE app servers on that system. So I want to have a machine as big as the one I have in production. If you do, then it's going to be the same or faster running reports on the target machine than on the production machine. If you run a smaller machine there, you're hurting yourself because you can't really run disaster recovery on it, and it could affect the replication target. So it should be faster in most cases.
So there is a follow-up question: can missed changes be recaptured or requeried?
Can missed changes be recaptured? Okay, so now we have to ask about is it Pro 2 replication or is it OpenEdge replication? OpenEdge replication for disaster recovery, there won't be any missed data because it's handled through the AI files, through those notes, so that's not a problem. If it's Pro 2 replication and something for some reason doesn't get moved or doesn't get copied, yes, we have log files and we can start to see, we can use those to say, hey, this record didn't get copied for some reason. That'll be thrown in an error as an error in a log file, so we can keep an eye on it. So yes, it is possible, and it's nice to know that that one, you had a record that has a problem, you want to go look at it, and it can be re-added at that point.
All right, here's one about a question about switching over to 12 from someone who's on 11.7. So they're currently running 11.7 CUI and web speed. I hope I said it correctly.
Yeah, Chewy. Yep.
Chewy. Sorry,
yep.
Chewy. Just looks strange to me. Would we improve performance by implementing PASOE before switching over to 12?
That's a really good question. We have gone in and helped customers move from 11 to 12. And we have gone in and set up our Pro Monitor, which again monitors the performance of the system for a couple reasons. One, so we can make changes when they go to 12, but two, to make the time to do the conversion as most performant as possible, right? So if you're doing like a pro to pro, or you want to make sure that the conversion goes as fast as possible, then having that on there and have that before you move is a good idea. Uh, However, in version 11.7, there is no web speed. There's only PASOE. So that is one of those things that, yes, you want to get the database tuned and want to keep it running well for the conversion. But for web speed, you're going to have to convert that to PASOE anyway, and that will mean new tuning once you get on version 12. So I hope I answered that. If you have something more specific, let me know.
You can always just put the question in the questions box or in the chat. And I think someone just commented that 12.6 has web speed, correct?
I'm sorry, that what has web speed?
12.6?
No, version 12 does not have any web speed or classic app server. It only has PASOE. Now, PASOE runs classic web speed in most cases, right? As long as you're not using tag extract, which is code written with HTML code that then somehow merges with ABL code, then in most cases you can run web speed in PASOE. So it's technically web speed, but it's running in the new PASOE server.
All right, there's a lot of questions that are coming in for you today, so I hope you're ready. All right, so here's one. What would be your strategy for dump and load of a 9 terabyte database? A lot of delete archive has been performed in database analysis detecting 4.9 terabyte now. So there's lots of physical space to recover, but the downtime window won't allow a regular binary dump and load.
Yeah, the only way to do this in a timely fashion is to do the pro to pro, right? We would set up we would take your original database, we would set up some time to set up CDC or triggers, and then usually an hour of downtime. And now that database is ready to start replicating and using Pro to Pro. And then we would stream that data over to another database. And this could take 3 weeks, 4 weeks. But during that time, your production database is up and running. Once everything has been streamed over and your new database is built, it's going to be much smaller, you're right, because you won't have pockets of space in there that aren't being used. And then you could you shut both of them down. You have to do a couple things to the new database because it has pro to pro tables in it that need to be removed. So that's like a 4 to 8 hours or less, depending on the size of your database. But it's also your time to check to make sure all the data went correctly. It's not usually a problem, but the business needs to know it went well. So that's your downtime, right? A couple hours up front, 4 to 8 hours, maybe longer at the end with a large database like this, but not days. Should be able to get it done in a day.
Okay, so there was one follow-up for that. I've seen a very busy system, the same one with the 9 terabyte database, always falls behind on replication sync over WAN. Are there any plans for compression over replication?
I know we've made changes to replication to make it more performant in the 12 timeframe. I don't remember if that was one of them. I know we can encrypt now. I'd have to look at that, and I can do that if you. Remind me, and I'll send that answer out to everyone at the end after the meeting.
Okay, I'm writing a note too to myself, so
okay.
There we go. All right. All right, so there was another question that says, when reading some articles, the general conclusion was to use a 4K block size on Windows. You said earlier 8K should be used on Windows, so now this person is confused. Do you have a recommendation for that?
Windows can now handle 8K block sizes, right? I mean, that was an old limitation on Windows. If you should be using 8K if you can. Again, right? We read a whole block size into memory. So if your database is in 8K and we read it up, there's more chances of records being in there or your record fitting in everything. I will verify that, but that was an old requirement, an old limitation on Windows years ago. So I will verify that, and I think we're going to answer all these questions again and send them out after the fact. So I'll verify that and get it back to you.
I'm just gonna.
I've been around so long, I forget what's changed and which
Yeah.
hasn't.
Okay. All right. So we have a bunch more. So we're going to try to keep it as close to the top of the hour. But Roy, do you have a few minutes to stay after if we have one or two more
Yes,
questions? Okay,
yes, I do.
perfect. All right, awesome. What are the steps and parameters we should consider when switching from 10 to or 10, 11, 10 or 11 to 12?
Well, converting the database, if you're staying on the same platform, is easy, right? You move the database over 11 and 12, and you convert it to 12. And now you have a 12 database, and you can start it with your old parameters, but there are a lot more parameters. There are a lot more things you can tune. So those are things you have to look at, and that's all in our documentation. There's a what's new in 12.2, 12.2.1, what's new in 12.8, 12.8.1. So there's a lot of information out there that gives you all the things that have been changed. The primary things in a database is one, there's now server-side joins, which means the database will be joining some of your queries on the database. So you might want to have a little more CPU and memory for that. The other thing is that the version 12.8 database has multi-threading in it, right? So the servers that connect using remote have multi-threading so that nobody's waiting in line. Again, that might have more CPU on your system. So these are the things that you want to consider when you're moving from 10 or 11 to 12. The other thing that you have to consider is, when's the last time I did a dump and load? How's my database now? Right? If I haven't done any maintenance on that database and it's fragmented and it needs and it's in type 1, now's a good time to dump and load that database so you get the best out of it in version 12. You're in type 2 areas, you'll have less fragmentation, you won't have to dump and load as often. So those are the things I think about. Specific parameters, the fact that you can change the parameters on the fly is fantastic, but there are a few parameters you shouldn't be setting anymore. Some people had -hash set from years ago. They moved up to 11.7. They were having bad performance. We turned -hash off because we do it for you now, and their performance came back. So some specific things that might cause you problems, but nothing specific I want to talk about for parameters.
Okay, so I see I have two more questions, Roy. Let's jump right in. Are there any other default settings that should be modified other than the BI cluster size?
Oh, gosh, probably. I'd have to think about that one.
Okay.
There's an awful lot of settings, and we change an awful lot in the DBA team. So that's one of those reasons why you want to have it well tuned on your current version before you upgrade, and just take a look at how your systems. Again, default settings are default settings, and I say in other things, the default is always wrong. When it is right for you, that's not the usual. A default setting is what somebody set thinking that was a good place to start. So if you're using default settings, you want to review all of those, and you want to do some monitoring. Again, monitor and see where your bottlenecks are and where you can improve, and then change the default settings. So I wouldn't just set a list. There probably are some that were the defaults I just know are wrong, but I can't think of them now. So we'll try and get more information on that one when we answer all of these. So.
All right, let's get into that last question that I had. Can you provide recommendations for indexing? This person is using a third-party app where some of their tables have a ton of indexes, many of which are redundant. Any suggestions on index tuning?
The only thing we do with indexes is we make sure that they are compacted, right? So they're close by, the levels aren't too deep, and that's by running the index analysis and take a look at how badly fragmented and how badly they're being used. And if you're getting a value back between 60 and 90, a good idea to compact that index, get all the indexes back closer together, keep the levels down. If you have too many indexes or too many redundant indexes, that's a process of going through each table, taking a look at them. There's a ways you can see what indexes are being used by code. XREF, I think, is called. That's more of a application type review that will tell you if you can remove indexes or tune the indexes at that level. So
All right, one more just came in, Roy, so I'm gonna ask it anyway. So sorry, I just spoke. All right, so the SQL queries, and this will be the last one. The SQL queries can be seen using SQL logging on SQL server type. Is there anything similar for 4GL planned, like seeing query plan and other insights?
well, yeah, if you're using a client, you can a 4GL client, you can turn logging on that client, right? So it's just a log setting on the starting the client. It's a and you can set how much logging you want it to do and that type of thing. On the server, no, right? On the 4GL server, no. That's in that case, it's just serving the data up, and SQL is doing more. It's actually rebuilding that query for the OpenEdge database. So there's a lot more information in there. And of course, um, there's always turning on statement cache every now and then to find out what the 4GL is doing, what's happening. I don't know of any plan to do any more than that. We have added a lot of things in 12.8. We've added memory tools that you can use against 4GL, and you can do that live. We've added performance that you can do live on a lot of things. So there's been a lot of work for that. And again, there's been statement cache in the database for a while. So I don't know of anything else. Again, go to openedge.ideas.portal and see if there's anything there that you like, and if there isn't, make an enhancement request. Again, and then get all your friends to vote for it. The more votes you get, the more chance it'll show up in the next release. So,
All right, Roy, I think that's all the questions that have come in. So
run them out.
yes, someone just said thank you. So I think that's all the time we have for today. Sorry for everyone for running a minute or two over, but we wanted to get to as many questions as we could. And Roy, thank you for staying. And from all of us here at Progress, we hope you have a great day and evening. So enjoy
Yep.
the rest of your day.
Thank you very much. Thanks for
Thank,
joining.
thank you.